Forget the classic image of an ape slowly standing up to become human. Our evolutionary story actually begins with an apocalypse. 65 million years ago, a 10-kilometer-wide rock slammed into the Yucatan Peninsula. The collision detonated with the force of millions of nuclear bombs, throwing up enough pulverized rock and ash to completely choke out the sun. This triggered a severe, decades-long impact winter that suffocated the planet and eradicated 75% of all life, including the dinosaurs. While giant apex predators starved on the frozen surface, a completely different group of animals was hiding deep in the dirt and underneath rotting logs. These were our earliest ancestors, tiny, rat-like mammals that seemed entirely unremarkable. In a ruined, desolate world, being small was a practical necessity for survival. Because their bodies were so tiny, they required barely any calories to stay alive, surviving entirely on buried roots, dead insects, or ash scavenged in the pitch dark. They also possessed a trait the giant reptiles lacked: warm blood and a coat of insulating fur. This internal heating system allowed them to stay flexible and hunt during freezing temperatures that paralyzed the remaining cold-blooded predators. If that asteroid had missed Earth, massive reptiles would likely still rule the surface today. By ending the reign of the dinosaurs, the impact created the opening these tiny predecessors needed to multiply and inhabit the planet. As the dust settled and sunlight returned over millions of years, the Earth slowly recovered. Our surviving ancestors moved up into the newly grown forest canopies, developing grasping hands and binocular vision to accurately judge the distance between branches. Then, roughly 20 million years ago, deep tectonic shifts tore the continent apart in eastern Africa, thrusting up massive mountain ranges. These towering peaks blocked vital rain clouds, causing dense jungle canopies to wither away into vast, open, dry savannas. This sudden environmental collapse forced the primates living there into a brutal choice. They could either starve in the shrinking trees, or they could climb down and take their chances in the dangerous, tall grass of the open plains. For decades, scientists debated how our ancestors managed this transition. The answer finally emerged in 1974, when researchers in Ethiopia unearthed a fossil belonging to a young hominid. They named her Lucy. Looking at the lower half of her skeleton, the specific shape of the pelvis and leg joints provided absolute proof that she walked confidently upright. The evidence showed bipedalism, walking on two legs, was a mechanical adaptation to see over the tall grass, occurring long before we developed high intelligence. Committing to walking upright meant our ancestors' arms were freed from the burden of moving around. With hands finally available to manipulate the world, species like Homo habilis began deliberately smashing rocks together to create the first sharp cutting tools. The human diet changed when Homo erectus tamed fire. Fire provided heat, but more importantly, it introduced the practice of cooking. Breaking down raw meat and fibrous roots requires a tremendous amount of muscular and chemical effort from the stomach. Cooking effectively pre-digests the food outside the body, drastically reducing the physical workload on the digestive tract. This chart perfectly illustrates the resulting biological trade-off. As the energy required for digestion plummets along the bottom axis, you can see a direct inverse spike in cranial capacity. The human brain quickly doubled in volume, jumping from roughly 600 cubic centimeters to nearly 1,300. Fire served as a biological shortcut. It offloaded the hardest parts of digestion to an external source, funneling a massive surplus of calories directly into expanding the hardware of the modern human mind. Looking at this schematic, you can see an anatomical contradiction known as the obstetrical dilemma. Upright walking required narrow, compact hips for balance, while our new calorie-dense diet was rapidly expanding the size of the skull. Where these two competing evolutionary pressures collide is the birth canal. Pushing a massive, highly developed cranium through a skeletal structure designed for running made human childbirth one of the most mechanically difficult and dangerous processes in the animal kingdom. Nature's only workaround to ensure survival was early eviction. Human infants must be born incredibly early in their development, emerging entirely helpless and immature compared to a deer or horse that can run within minutes of birth. A human child requires years of constant carrying, feeding, and protection. This extreme vulnerability meant a single mother could no longer survive and raise an infant entirely on her own in the wild. Isolated individuals were forced to band together out of absolute necessity. Our greatest physical weakness literally mandated the invention of the tribe, hardwiring empathy, mutual defense, and community directly into our survival strategy. Even with these complex social structures, Homo sapiens were far from the only humans on Earth 100,000 years ago. We shared the continents with several other distinct hominid species, including Neanderthals and Denisovans. We didn't conquer them through sheer force. We lived alongside them, shared resources, and interbred. We absorbed vital genetic material that granted our ancestors the robust immune systems required to survive the bitter cold of Europe and Asia. The final upgrade happened roughly 50,000 years ago. Scientists refer to it as the cognitive leap, a transition into abstract thinking. For the first time, a species possessed the neurological wiring to imagine, illustrate, and discuss things that did not physically exist in the material world. This shared imagination allowed thousands of complete strangers to trust one another. Because they could believe in the same invisible concepts, like shared mythologies, behavioral laws, and eventual nations, they could cooperate on a scale no other animal could match. The ability to coordinate tens of thousands of minds under a single unified belief system directly resulted in the construction of massive, deeply complex civilizations. We see the exact same cognitive ability manifesting across different continents, like here in the ancient river valleys of the Indus, proving that our capacity for shared fictions is the bedrock of the modern world. Modern humans are the result of 65 million years of continuous adaptation. Our species was triggered by an asteroid, shaped by a shifting climate, and ultimately saved by our unique capacity to imagine and connect with one another.